Okay, so let's build off of what I did in our previous lecture. Oops, that's not what I want. And I just want to put it into actual writing so we have some sort of rule, I guess, to think about. So we defined the hydrolysis of a salt as being an ion dissociating in water. And we talked about looking at the strengths of the salts to see if something was going to produce a more acidic or basic solution. And now I just kind of want to bring that back into focus. So I have the two examples here. One is going to produce a conjugate acid and an OH minus. And what is this reaction? This is baking soda. It's sodium bicarbonate. So this would have started off as like Na, let's see, 2CO3. And if I add that salt to water, the dogs are not being my friends today. All right, so if I put sodium bicarbonate into water, what am I going to get? Well, I'm going to get dissociated sodium ions, so 2Na plus, plus these carbonate ions, so this CO3, 2 minus, and then water. Then I can look at this and say, okay, so how much further is this reaction going to go? And the one thing that we were talking about on the other lecture is that sodium, well, the only thing it can do is accept OH minus. So that would be a strong base. Therefore, adding sodium ions is not going to do anything to our solution. So we can focus on what is going to happen with our CO3 2 minus. This is what tells us whether or not we are increasing or decreasing the pH of a solution. So this is the reaction that I have written up top. So what do I know about this? Well, I've formed OH minus. That means this conjugate acid is much weaker than this OH minus. So adding this to my solution is going to make it more basic. And in fact, that is one of the things that we use sodium bicarbonate for. And if you look in our labs, which one day I promise you will get in there, you will see that we actually have baking soda, and we'll use that to help neutralize any kind of acid spills on the workbenches. So it is a good neutralizer and something that we take advantage of. The one thing I wanted to point out with this is that this reaction that we have here is I don't just have carbonate ions floating around that I can like grab off the bench top and throw into water. It's going to come as a salt that I'm going to dissolve or have dissociate in my solution. And this is the actual salt that we're talking about. This is my ionic salt. The thing that does the magic and it increases or decreases the pH then is the salt that will actually interact with the water. So that was a big part of what we were doing in the last lecture. Now let's see, this is ammonium in water, and this could be any of my halides, right? I could have like Cl. I wrote this in the wrong way. That was messing me up. NH4Cl. Yeah, there we go. I could have what else could I have? Anything from there, really, right? I could NH4Br. Anything with a -1 charge will form a salt with this ammonium. So I would take something like this and throw it in water, and then I can look at this and be like, okay, so Cl dissociated in the water, and Br, well, these are my weak times 10 to the -80 bases. So they're not going to contribute at all. The only thing out of that salt dissociating is going to be this ammonium. So then we can look at what is going to happen. Well, ammonium can't accept any more hydrogens, so it's going to donate a proton to my water, and I'll get my H3O plus and ammonia. So what is this going to do? Well, this is going to make my solution more acidic. So let's take a look. We want to recap some things before we start doing some math with this. So we are talking about hydrolysis of an ion, the salt ion reacting with water, And if I add an acid to water, what's going to happen to the pH? Is it going to go up, go down? Nothing's going to change. You can't tell without any more information. Good, yeah, it's going to make it more acidic, so the pH is going to go down, right? Acid to water, pH goes down. And conversely, if I add a base to water, that is going to increase the pH. So just going back to the examples on this page then I know that these salts that I added to the water are going to make my solution more basic or more acidic. So the first raising the pH, the second lowering the pH. Now what happens if I add both an acid and a base to water? What's going to happen to the pH? The trick here is many people will say nothing because you're assuming that you're going to have an equal amount. So if I add a compound that is both, is going to dissociate into an ion that can be both acidic and basic, so two separate ions, right? And one can be a proton acceptor and the other can be a proton donor. And that doesn't mean that nothing is going to happen to the pH, because what we're going to need to do is figure out which one is going to dominate. And we figure out which one is going to dominate by looking at what? Okay, I hinted at it in the other lecture. I said, so we can look at this chart to see which one is going to be stronger. But the thing that you can do is look at both your Ka, hello, your Ka and your Kb. If I compare those, if my Ka is greater than my Kb, well, what's that saying? That's saying that I'm going to produce more acid. So I am going to decrease my pH. And if my Kb is greater than my Ka, I am going to increase my pH. Sorry, the dogs are making this really hard to keep my train of thought in line. So let's take a look. Sodium fluoride, that's something that is added to drinking water for teeth. It isn't added in Bellingham, but we want to know, is adding that to our water, fluorine to our water, going to make it more acidic or more basic? What do you think? Okay, so let's write out our reaction. Let's see if this thing is going to change on me again. So NaF is going to give me Na plus fluorine ions, F minus. Let's just add our water to remind ourselves that we're reacting those in water. And we want to see what kind of reaction are we going to have. So I've already said that the sodium, that's not going to do anything. So the reaction that's going to actually matter to us is going to be this. So I'll have my fluorine ion plus my water. And what is that going to do? Well, fluorine, it can only accept a proton. So that's going to give me this weak acid and a hydroxide ion. So this is the only thing that can happen that would change my pH, because remember the sodium ion, that would be NaOH. That's not going to happen. So it would be the weak base, which is my fluorine ion. So how can I get my Kb to try to figure out how much fluorine and hydroxide I'm going to have to know what my pH is going to look like when this is done? Well, remember, we have this expression that Kw is going to equal my Ka times my Kb. Now, while we know that Kw changes for a given temperature, it's still going to be Kw. So at whatever temperature, you just need to look up what the Kw is. But say it's at 25 degrees C, then I would have my 10 to the negative 14 is my Kw, divided by, well, I want my Kb. I'm going to be able to find a Ka value for fluorine. So I divide it by its Ka value that's listed, and that will give me the Kb. Then I can take this whole thing and do my rice table and solve for things just as we've been doing before. So now let's think about this. This ammonium nitrate we use to alter the blood pH. It's something that's given to people in hospitals if, for whatever reason, they have managed to alter their pH in their blood. So the question I have for you is this: is this being used for acidosis, where somebody's blood pH is below 7.4, or alkalosis, where pH is greater than 7.4? Let's see. Okay, NH4, NO3 plus water. What kind of ions am I going to get? I'm going to get like NH4 plus and NO3 minus, and then water. It's like the first step. It's just dissociating. So what we want to know is which one of those is going to actually interact with water to produce something with either hydroxide or with ammonium. And I know that HNO3, that's a strong acid. So that's just like saying that sodium ion or chlorine ion or bromine ion. That tells you that those things, they're not going to do anything to contribute to the pH of the solution. Therefore, the reaction we're actually interested in is going to be this, plus H2O. All right, so what's going to happen? Well, I can't accept any more hydrogens. Nitrogen is like all filled up. So that makes this a weak acid, and it makes water my weak base. So I'm going to end up with ammonia plus H3O plus. So if I give this ammonium nitrate to somebody, then what am I going to do? I'm going to lower the pH. So what I would be doing this for is that somebody with alkalosis, if their pH is too high, then you can give them this compound under proper medical supervision done by a doctor or a nurse and not ourselves. Just want to clarify that. You would give them that compound, and that would decrease the pH. So if my pH is too high, that would be the medication that I would take.